recommendation session. So hi, myself Ravinder, and with me my colleague Anshul. So we will be discussing about the basic stuff of what exactly is a recommendation system, where are they being used, and how exactly to implement them and how to test them. So few of the stuffs I think even before moving to this, right? We all used to watch movies. We all used to go to theaters. Generally, we ask our friends recommendations, right? How was the movie? How are the feedbacks? Or we generally check them. Okay, what are the ratings that we are getting for that, and follow them. So generally, if I look 10 years back, the recommendation system was majorly manual. But now, with the digitization of world, people are moving more towards online. Even organizations are more into selling their stuff online. Even for restaurants, if we say people prefer to put an order online, get their food at home instead of visiting to our restaurants. So considering all these things, recommendations for everything has become really important. So what exactly is a recommendation and how exactly the recommendation system comes in place? So I think all of you would have seen when you browse Amazon.com, you generally see a bar at the bottom that you might like, and you will see some products. So suppose you are searching for a smartwatch, you will see something like that they will recommend something. Okay, you can buy something else that is similar to you. Or the other stuff that can be related to recommendation is that based on the items that you have purchased or whatever your history says. So suppose if I was browsing for some of the maps, it will show me those similar maps. So that's based on what I was searching out there. Or there can be other stuff when you see the recommendations are based on daily basis, how exactly people are browsing. So suppose there are some daily recommendations that comes, okay, at this particular day, these are the recommendations from the organizations. And one final use case can be what other peoples are buying out there. So recommendation is, it is just a purely suggestion that may or may not actually be actually feasible or relevant to you. So there are various strategies, various algorithms that are being implemented to implement these recommendation systems. And on basis of those only, you see some suggestions when you browse all these online portals, different stuff to buy in out there. So in this particular series today, we will discuss about how exactly are the recommendation systems being built, what are the different categories of those, and how exactly they can cater to the different needs of the users. So why a recommendation system? What was the need of that? So like I mentioned, uh, in the digitization world, people are moving more towards the digital stuff out there. So instead of visiting for any shopping, I would like to go to Amazon, go to Flipkart, buy in stuff out there. The second stuff will be that if I'm going to buy something, I would like that it is to be personalized as per my needs. If I have to see something and if I have to search for that in 10 million stuff, it will be difficult for me. So that's why the recommendation systems came in place, majorly due to two reasons: how exactly they feed the need of those two strategies. So in every online system, there are two parties. One is the buyer, the personal system. So how exactly it will benefit that personal. And second one is the business who is actually selling those items. So how exactly it will benefit that business. So considering those for the personal stuff, for the personal needs, what recommendation system does, it identifies the products which are most relevant, which are showing you your personalized content. So suppose if I'm browsing Ghana.com, I am logged in and I have put my interest out there. So next time it will show me a playlist that will match my stuff. So I don't have to search for thousands of songs for my personal stuff out there. So that way, even I get benefited when I'm getting some personal recommendations out there. Second part is the business out there, right? So as a business, if I am suggesting you what you are liking out there are more likelihood that you will buy in that particular stuff more. So even business are getting benefited from that, that instead of you coming there and searching for thousands of products on my portal, I will suggest you some good things. So suppose if you want to buy a headphone, and I will suggest you some things that are actually related to headphone also. So suppose you need a head wire also with that. So there is more likelihood that you will buy both of those products in a single go. So that's how the personal also benefit, business also benefits. There have been case studies that are being done that Netflix, I think it was in 2009 when Netflix did uh, actually spend more than $1 million out there just for increasing their recommendation. So they put a hackathon so that their recommendation systems can be increased. So that's actually is the visibility of these organizations, that how important they consider the recommendation systems that are there in place. So these are few of the major domains or organizations, kind of media, I would say, that uses the recommendation systems. So the major domains are media, be it your visual as well as the audio out there. E-commerce, one of the major users, you browse any of the e-commerce sites and you will see your recommendations out there. Job portals, whenever you put your recommendations, a general recommendation can be, okay, I'm searching for a job in this particular area only. So you will get the job recommendations for that area only. The travel and the real estates, depending on your past history, where you have traveled and all those, they will show you some packages out there which are actually relevant to that. And finally, the education. So if you are doing some course online, they will suggest you some other related. So if I'm doing some MLAI course out there, it will again show me some of the recommendations or some of the good courses that are available into the same area. So these are major of the domains that are getting benefited from the recommendation systems, and are actually investing in these so that their business can actually enhance and they can get more gains from there. Okay, let's move and understand what are the different types of recommendation systems. So like I mentioned, recommendation is just a suggestion, right? And suggestion will be based on certain attributes, certain criteria, or whatever information you share with those organizations. So based on different attributes or different similarities or dissimilarities, we categorize recommendation systems into majorly three categories. One will be popular based. So popular is kind of what is popular in your area, what is popular in your geography out there. So we will discuss this in detail. Second one is the content based. Content is what exactly you are buying, the attributes, the particular product out there. So how you can categorize those things, that will come into content based. And third one is the collaborative. Collaborative is more around that if you compare, okay, what are the similarities between various users. So if your algorithm is based on user to user similarity, then it will call user collaborative filtering. And if it is based on item, means you are comparing two items that you can actually show and actually suggest to different users, then it will be collaborative recommendation system based on items. Let's see all this in the detail. So let's start with the popularity based. So like I mentioned, popularity is what is popular in a particular geography. So suppose if I'm browsing Netflix, right? So if I'm not logged in onto not Netflix, or I'm browsing something, I'm browsing Ghana.com and I'm not logged in, means I haven't shared any of my information with that organization or with that portal. So on what basis they can recommend me something? So that recommendation comes from popularity. Popularity means what exactly people are liking in your area. So suppose if I take this example, money heist, we all know it's the trending now at the moment, right? So it also shows, so whether it doesn't matter whether you like it, you don't like it, whether it is your priority, it is not priority, depending on the trending now in your particular area at that moment. Some of these portals, some of these, they show what is trending at that moment. Even on LinkedIn, we would show, right? There will be multiple times when certain articles or certain posts, they will be trending at that moment. So what exactly is trending means more and more people in your geography are actually liking it. So it has no connection with your likes or dislikes. It's more around what more people are liking in your geography. So that's why I mentioned why not to use popularity based algorithm. So the concern out there majorly is that people are not actually getting personalized stuff out there. Now, no matter whether I like money heist or not, it will always popping up for me to showing, okay, this is the trending one in your geography. So that's major limitation with the popularity base, that it will show you the generic content instead of showing a specific for your purpose out there. So that's why the enhanced algorithms were being implemented for recommendation systems. And the next in the series is collaborative filtering. So like I mentioned earlier, the collaborative filtering is majorly of two types. One is the item based and second one is the user based. So what is the item based filtering? So if you see in this figure, so suppose there are three users, okay, and these days considering we are logged in into our houses, so even our groceries we are buying online, right? So suppose I'm user one, and when I go and buy fruits, I buy a melon, I buy one apple, and I buy one banana out there. So my purchasing trend is that I'm buying all these through three fruits in a single go. When user two comes, when he is buying the melon, he is also buying apple out there. So he has bought two fruits there. So considering this trend, when the next user comes, when the user three comes out there and he says, okay, I have to buy apple, then by default, the system can recommend them that people who are buying apple are also buying melon. So it means you are getting a item to item similarity, that people who are buying apple are also buying melons out there. So you are comparing items there, what you are selling. So you can actually show those items to the people that, okay, when I'm buying A, you can also buy B there, because the people who have already bought A, they are also buying B there. So that's called item-based filtering, where you compare items with each other and suggest to the third user. So the suggestion here is not to myself, the suggestion here is to the third user out there. Next one is user-based collaborative filtering. So pardon me, kind of a foodie, that's why I have put major of the examples into the food out there. So suppose there are two users. So when one person is buying pizza, he is also buying pasta with that. And when he was buying pasta, he ordered Coke with that also. Now there is one other person with a similar characteristics who also buys pizza and pasta there. So because those two people are similar in likes, dislikes, or whatever they are buying online, on basis of that, when this person comes, you can recommend them, okay, other persons with pizza and pasta are also buying Coke, so you can also try out Coke there. So the recommendation for that person will be Coke. But here the recommendation will be based on the matching attributes of people. So I have certain likes. I'm liking suppose vegetarian foods, and I'm just doing vegetarian orders regularly for these two types. This person is also doing the regular orders of vegetarians of this type. So because these people are matching out there, that recommendation will be done on basis of attributes of those people. So based on the likes and dislikes of people, you can recommend a third stuff to the people. So here the comparison is happening between user to user. So that's majorly collaborative filtering. One is item based, second one is user based. Depending on what actually is in more demand out there. So suppose if I consider example of e-commerce, which bother more about their products and they want to sell products together, so they can actually go with the item based similarity, because that actually reduces their overall surface that what they need to compare. But if on the other side, if I take example of Ghana.com, where likes and dislike of people matter, what that person is liking out there. So there, the user-based filtering matter, that if people of these kind of characteristics are liking such kind of song, you can recommend the other songs to the other people out there. Hope this clarifies both the filterings, the collaborative stuff. Okay, the final one on this layer is the content-based filtering. So the content-based is kind of similar to the item-based, but here the suggestion is being made to that user only. So suppose if I'm watching some certain set of movies out there, so the system will suggest me some other movies out there. So here, the system is not comparing anything else. The system is just comparing my likes and dislikes. So suppose I am watching fiction movies from last 10 days. So it will automatically pick up few of the fiction movies and will suggest to me as a good to watch out there. So only difference between item based and content based is that there the suggestions are being done to the other folks who are buying a similar items out there, but here the comparison is that it is suggesting to the same user. I think this side makes it more clear that what will be the user difference between collaborative filtering and the content-based filtering. So here we can see that these two folks, they were liking one thing. The second person is liking one thing which can be recommended to the second person out there. So here it can be either similarity between users or either similarity between their likes or dislikes of the elements. But in content-based filtering, what I am reading out there, if there are any similar articles or any similar product to that, then it will recommend to me. Consider being a family member, I always go and purchase the kitchen materials out there. So if I am going to buy one stuff for kitchen, it will automatically recommend me the other stuff for kitchen that are available out there. Okay, hope this makes it clear, these two kinds of filtering out there. Now, a general question will be, what was the problem with the popularity system? The popularity system problem was that it was not giving you any recommendations when you don't have any history, any purchase history or relation with the organization, or ideally you haven't logged in out there. And what was the problem with these filtering systems is that when you are going first time to them, how exactly they know that what they need to show to you. So the ideal implementation that goes for all of the systems on all of the products out there, that people generally implement hybrid recommendation systems. So that when you are initially approaching those guys, when you are initially going to a site, basis of your categories, they can take one algorithm. And once you are well versed into the system, they know your history, they know your purchases, they know what your likes and dislikes. So they can pick up another system out there for the recommendations. So this is just a simple example where we are actually clubbing the content based and actually the other filtering examples. Then there can be a simple combiner and you can get the recommendations out there. Similarly, we can club all of those algorithms that we will see practically when we go further. So 90% of the organization, they will have hybrid recommendation systems in place, that depending on what kind of users or what situation the user is in, they will give those recommendations to the users. So that's majorly as per what is a recommendation system and how exactly it is being used by different organizations and how exactly it is impacting their business. Now Anshul will brief that how exactly we can design a recommendation system, what are the practicalities and what are the algorithms that can be implemented, and then how to test those algorithms out there. Over to you, Anshul.
Hey, thanks, Ravinder, for sharing out the details that what are the things in the market. So, guys, let's just keep it as a two-way communication and just not that we are bombarding with you with our thoughts. So, I think the problem, it's right, IT folks, we have to solve the industry problem and we have to generate a cash flow. That is what is asked from the upper management, right? And if you see it from that perspective, uh, Amazon was able to make close to 30% of their total revenue from recommendation systems. That was close to 12 billions. Now, this is the power of one algorithm, which is just suggesting you thing, but it's making that much business, right? And even I think Ravinder also talked about that Netflix and all that, where you see that, hey, this is how I can engage the customers and then increase the sales and the cross sales. So that is the problem that is solved by recommendation systems. So I think so. Just to take you that what it really looks into as we see. So if I just go to Amazon, right? Let's say that I'm not logged in, and I just say I go to the Amazon. So let's see that what it gives to me. So here you can see that COVID is going on, so you must see that there should be a personal safety supplies, right? This is the thing which is in demand. So this is what you see as a popularity based thing, because now because of COVID, right? You see that, hey guys, let's buy masks and hand washers. Now, when you go or browse over here, you see that see personalized recommendation, sign in. Okay. So whatever you are seeing over here is a popularity base, what we talked about, and it's just based on either on the kind of what people are browsing or whatever the highest number of sales of the item they had. So it's based on that. Now, the problem was that, okay, hey, this is not, so now in the era of information overload, right? So we generally want to subscribe only to the information which is kind of we want to hear, right? And that's why you see that nowadays even technology is building us that you don't have to read a whole newspaper. You just have a few articles summarized well for you, right? And so that's what the recommendation job is doing. You don't have to go and browse, let's say, whole inventory. It just suggests you that what is a similar thing. It is there in the market, right? And earlier, this role was played by your well-being or the friend circle, where you just say that, hey, I watched this movie. This is really cool. You just go and watch this because we just have the same taste and we love, let's say, the action or the comedy movie. Now, just understand that that has been replaced by our algorithm. So that is the power of recommendation system. Uh, so before jumping to the recommendation system, how to implement it, few concepts in place. So guys, any questions so far? Okay, silence means no. Uh, so as Ravinder told us that we want a personalized recommendations. So that's why we went for a collaborative one. As collaborative name suggests that you just go well together with each other, support each other, and then you would be able to get the results, right? So let's see that how it works. So uh, here, let's say this is just a simple metric. Okay, you can just relate to the guys if you just keep busy making Excels in your project too. So this is just movies. So Finding Nemo, Toy Story. So these are my movies which you can see on the column, and these are my users which you see in every row, right? Now here, if you see that user one has rated a Finding Nemo and a Toy Story as 5 and 4. Similarly, if you look at the user 4, it has also rated the same 4 or 5, very close to it, and similarly user 6. So this tells you that okay, user 1, 4, and 6 have the same taste, right? And in the collaborative system, the first thing that you have to have in the play is user interaction matrix. Okay, so you can see that these are my users and these are my items. So you have to have user item interaction matrix in place, and that's a problem. That's why you see that we call it as a cold start problem. That obviously once you go to the Amazon and just log in and create an account, uh, they cannot start recommending you a personalized content from a very first day. They would able to make you that what is your likes and dislikes once you start doing some shopping, you browse some articles. So that is nothing but they are capturing a user and item interaction metrics, and that is what it looks like. Okay, so that's why in the collaborative you have a cold start problem, and that's why when Ravinder talked about that in production, it's not always a single thing that we keep. It's always an ensemble thing. Hey, okay, once you come first, this is what a popularity base. Once you have a few interactions, hey guys, let's have this collaborative filtering for you. So it's always a hybrid model. Okay. So for collaborative, whether it's a user based or item based similarity, this matrix needs to be in place. So for user based similarity, we just calculated, okay, hey, user 1 and 4 and 6 was having a similar taste. Similarly, if I would have asked you, hey guys, can we do it other way around? So I would have just taken this, transpose this matrix, would have made this rows as columns and these columns as rows, and would have done the same exercise for items. Now question comes that, hey, should we go for item based or a user based? So the best part of a collaborative filtering is that it changes with the taste if it changes. So for example, if I'm just watching a some action and comedy movie, and let's say that I just developed a taste to watch any thriller movie, so then it can start even recommend me the thriller movie too. So that's the power of collaborative, because you're just collaborating with someone and you're able to get the diversified recommendation. Otherwise, you would have missed that. Okay. And the question comes then, should we go for item based or user based? So because we have to compute a similarity between the items, right? So if you go with the user similarity, that is computationally expensive, because just imagine that if you have, let's say, Amazon, where you have, let's say, your users are in million, and I ask you that you calculate a similarity between those, that would be very computationally expensive. But let's say I just have an inventory which is, let's say, 100,000 or 10,000 of items. Calculating similarity between those would make sense. Okay. And just to give you examples so that you can relate better. So for example, if I ask that, so as Modi addressed in the last week, that, hey, we need to be Atmanirbhar, right? So he is basically saying that go and use more Indian made products, right? So in the recommendation system, for example, let's say earlier you were buying, let's say, X thing, right? And then you say that there is a substitute to it, which is just a item which is made in India, right? Our recommendation system can do that job very powerfully. Just recommending that, okay, hey, this is what my items which are built in India. Why can't you use those products? So this is the power of recommendation systems. Okay. The other one was so now the ask was that, okay, guys, we have a content-based recommendation system too. So what is the difference between those? So when I say, let's say that I bought a mobile, right, and I know that I need a, let's say, power bank or a mobile cover with it, right? That can be done through collaborative, but I'm just interested to, let's say, choose a mobile which is, let's say, having a 6 gig of RAM and my, let's say, 4 inch of screen. So in that way, I say go with the go with the content base, because here I'm more interested on features rather than interested that what goes best with it, right? So it's in if I talk about content based recommendation, it's just a replacement for you. But in a collaborative, it always have some complement products too. So that is the main difference. So in a content based, for example, if you're just searching for mobile, you will just look at that what is the substitute of that particular product. Okay. Now, before jumping to building a model, so just one thing, because our machines cannot understand English, right? It's qualitative data. It's not a quantitative data. So we cannot build a model from English, right? So there are, for example, let's say that I want to build a, let's say I have a movie data set where I say that, okay, these are my movie data sets and this is what the various genres in it, right? And I just want to give a movie which is, let's say, based on a description. So I just want to say that, okay, if this is a movie which is around, let's say, action, and this is what the genres I have, should I go for suggest a similar movie for that? So first you have to convert qualitative data into a quantitative. So there are various approaches that you can do. The first is the bag of words approach. So what it says is that, let's say that this is my movie review, for example. So just take every review, okay, and every word in the corpus should be as column. That should be the unique one, and whatever is present, just mark it as one. So this is known as document term matrix. Okay, and now when we build a model, you will see that how we can basically use this, and there are various ways that you can convert into a vector. So there is TF-IDF vectors, there is a word gram model, n-script gram model. So there are various ways that you can convert a qualitative data into a quantitative data. Okay, so I will just take a pause. Any questions? Are we really making sense? You're kind of off the topic. Okay, so let's continue. So let's made a recommendation system, and let's see that how we can basically use it. Okay. So here you can see that I have just I'm using this Google Colab notebook and Python library for building up a recommendation system. So there is already a library in Python known as surprise package, which you can use for building up a recommendation system. So here you can see that I have ratings data which was available on Kaggle. I just took that, and it has a user ID, a movie ID. So what rating I have given to that particular user, a particular movie, and at what timestamp, and what was the title, and what was the genre, and what was the year. So this is what my data looks like. Okay, and we will try to build a collaborative item filtering. So which means that which movies are similar, I want to suggest those, not on the user taste, but on the movies which are similar. Okay, so this is what my data set looks like. Okay, then I have just uh, uh, let's just view that how many unique users we have. So we have close to 2,800 unique users. And let's see that how many ratings we have. So let's say these are the ratings that we have. 200 max rating. A particular one user has given, let's say, 200 rating. Okay. And I just installed a surprise package, as I was telling you that this is the one which you need to have in place. Uh, so once you import surprise, so there is it doesn't work on a pandas data frame directly. You just have to typecast it to a surprise data frame. So this is what it does. So it needs what the user ID is, a title, rating, and a scaling from rate 1 to 5. So I just provided those information to it. Then yeah, here is the main concept. Whenever you test any algorithm which is based on machine learning, do not directly just test it from the functional approach that we take. It just needs to be done in a different manner. So what I did is that I purposely kept a training set and a test set. I just distributed it in a manner that it's a 75-25% distribution. Means what I train with my model, I won't use that particular training set to evaluate my model. Okay. I just did that. Then I am using, so there are ways to calculate a similarity between two things. So there are various ways to do it. So one is your cosine similarity, Pearson similarity, Jacquard similarity. So these are the ways that you can compute a similarity. So right now we just go with the cosine similarity. And cosine similarity, as we learned in just a trigonometry, that if the angle between the two vectors, so in kind of building a model, everything you need to represent as a vector. Okay. So whenever angle between those two vectors is 0, that means they are very, very common to each other, and they share the common traits. So I am using a k nearest neighbors algorithm, and similarity options, I just say that Pearson, and user based I said false, because I want to build a item based collaborative filtering. So I just made it as false. I just fit the training set and build my model. Okay. Now, when I build up my model, we will talk about this RMSE score later. But so once I build my model, what I just do is to ask that model to predict what the user rating would be. So for example, I just passed in the one particular movie ID to it. So it says that user rating was 5, but our model has kind of estimated it as 3.86. Okay, so this is what a recommendation system, because and was impossible false means it tells you that whether you have a rating available for that particular movie which you have kind of estimated was with you or not. So definitely we had. So that's why saying user has given 5, but your model estimated it as 3.86. Okay. Now, there was one more catch which I was saying was impossible false. So was impossible false or true means, for example, if I would have estimated for a rating which didn't exist for me, right? Then this condition would have been true. So purposely, let's take the ratings which are not available with us. So I just taken those ratings which was kind of was impossible and just tail 5. So the last 5 records. And I just say that, hey, can you just predict me for the UID this, and this is the movie description, and this is the uh, thing for it. So it says that user rating was not available, but your model has estimated 3.5. So we are estimating ratings on the scaling 1 to 5. So similarly, you would be able to do that. Now, question comes then that how to test the model, right? Whether it's good for us or not. So there are various things for it. So the first thing which kind of helps us to do this is the root mean square error. We'll tell you in detail that what it is. Uh, so basically, root mean square error tells you that what is your expected one and what is your predicted one. Uh, okay, actual and predicted, and it tells the difference between those. So, for example, if my predicted was let's say 5 and let's say actual was 4, so in that case, my root mean square error is just 1. Okay, so we need to keep that error as low as possible. Second one is recall rate. So it basically tells that what proportion of items basically user likes were actually recommended. So for example, let's say that I like 5 items, but let's say my recommendation engine suggested only 3 out of it. So my recall in this case would be 0.6 because my wish, what my liking was 5, but your recommendation system was just able to give me those out of those just 3 recommendations. So recall is 0.6. So whenever we go and evaluate it, it should also have a high recall rate too. Second is a precision. So it says that out of all recommended items, how many did the user actually like? So for example, if I recommend you, let's say 10 items, but you only like, let's say 1 item of it, right? So for example, if 5 items were recommended to the user, out of which he liked 4, the precision is 0.8. So similarly, high value. So we should have precision and recall should be higher to have a good recommendation system in place. Again, there is one more common metric through which you can kind of trace it. It's a F1 score, which is just not a harmonic mean between precision and recall. Okay. Now we have seen so far that how to evaluate things, but they do not tell you that. For example, I asked that, okay, hey, what is my, let's say, collaborative system? What is my root mean square error, right? But it doesn't tell you that what order they are. For example, if I ask you that, hey, tell me the top 10 recommendation list, right? And I saw that because top 10 is very crucial, right? So in that order really matters. So for that, you have to take care of order. To measure that, we have a MRR in place, which basically tells you that, for example, green represent a relevant item and red represent a non-relevant item. So for example, I do a top 3 recommendations. So my user one do not like these 2 recommendations and like the third one. So my reciprocal rank was 1/3 because I like third item. Similarly, user 2, I liked second item, so it's 1/2. And user 3 like the first item what I basically recommended, so it's 1. I just take a mean of it with the number of users, and that tells you what the mean reciprocal rank is. Okay, and again, it should be higher. Any questions so far? So, okay, we have seen, so this is what I was talking about. So testing set and a training set, the reason we keep this as 20/80 ratio, it's simple like that. For example, if let's say I have to teach kid, right, and if whatever I have taught to the kid, and if I just take exams based on the same, it might be the thing that kid might not have understood everything, but just mugged up those things, right? So you cannot ask the same questions what you have taught to that thing, because in that way you won't be able to see that whether your concepts are clear or not. It's the same with model. You cannot test the model on the data sets on which you have trained it. So that's why we have to keep a ratio 20/80 or it's 70/30. It depends on the way that you are kind of modeling into. But it's always that testing set should not be exposed before to model. Okay, and yeah, this is just that how we did that. So for recommendation system, we need, as I told you, that user item interaction matrix for collaborative filtering, and just item features in case of content-based recommendations. So these are the ways that you should approach for testing or validating a recommendation system. Questions? And guys, there are many problems that exist in the market as with the collaborative one. So shielding attacks also happens. So what I mean by shielding attacks is user creates a fake profile to kind of make their item appear higher in the list. So we need to be very cautious in that sense too, because if shilling attacks happen, so you would be kind of promoting up things which were really not liked by all users, but they are just a fake users. So that is what the challenge which is there in the recommendation system, and there are already few systems in place which kind of solves that problem. And in production, you never see one model in place. It's always an ensemble, which I mean hybrid model. Uh, so for example, if I just go with the thing where I just don't have a user and item interaction metrics. So to avoid that cold start problem, I go with the popularity based. And then once I have an interaction matrix, we go for the collaborative or item based thing. And generally, these data are not only they do a explicit capturing of data by asking you that give us the movie feedback, but they do also implicit tracking of you. For example, even if you go to Amazon and you just even try to even search something, and then you just go and look at your personalized recommendations, you would see that item too. So even that is how they collect the data. So whatever you are searching, browsing, right? So that also gets the user item interaction metrics done. It's not always that they explicitly have to ask the feedback and then you provide it. It's even they track that what you're doing in that case. Ravinder, do you want to add anything?
Nope, I think we are good to go. So, guys, this was more around setting up a context for recommendation system. That's why we covered the basic stuff out there, so that we have a fair understanding of that. We have a couple of live projects on recommendation systems, and the major effort from the QA side that goes is actually validating uh, the overall machine learning algorithms that are there. So, overall validation of that stuff. So surely in future podcasts, we will try to cover up the actual details and hands-on exercises for this. Thank you. Any queries, any questions?
So I think, yeah, I saw two questions, one from Manmohan Singh, another from Kishore. So Kishore is asking, identification of testing set is derived from requirements or from actual transactions. So answer is that we always do from actual transactions, and because you cannot get the test data sets from requirements, because requirement would be for the recommendation system is just to increase the cross sell or upsell. That is what a business requirement would be. And to design those solution is recommendation system, and you have to scrape the data either, and then you get implicit things, or you have to do some survey to explicitly get those details. Does that answer your question, Kishore? Okay, the next question Manmohan is asking, I think Manmohan wants to make money in such kind of economy slow. So he's asking, is there a recommendation system for suggesting stocks? Yes, so there are definitely models which do recommendation of suggesting stocks too. And even if you just want to prepare for that, you just go and have the data, and then you can just build up with the hybrid that model for recommendation system. For example, if you ask me that how to do with that, I would say that if it is, let's say, in this case, item collaborative filtering would be in a sense that should I suggest a share which is, let's say, falls in IT sector, the pharma sector. So if I say that, hey, I am, let's say, a person who just want to bet on, let's say, pharma, right? So in pharma, if you ask me to build a recommendation system, it should be just a item based. The other thing is that, for example, if you ask me that, okay, hey, I'm, let's say, a young person and I can take too much of risk. Why I don't want to just back through the large cap funds. I can invest even in short term funds. So that is what user based collaborative filtering would be. For example, if I have the portfolio which is more aggressive and you are also kind of lean to that, we can go for it. Manmohan, does that answer your question? Cool. Any other questions? You can raise your hands. We can unmute you.
No.
There is one more question. Please explain briefly how should we deal with fake IDs? Okay. So Shweta, you asked a very good question. So that is what I told you, that the problem currently, how to deal with the shilling attacks. So there are various systems which are in place. What they do is that they do time analysis for the IDs which have been created, and then they look out for that. Are they kind of suggesting a particular item, and were they existed before, or they were just all the IDs were created in that particular time frame to kind of boost up some sale or kind of brought down some item. So either it's a push or a knuckle. That is depending on that, we do that analysis. So that is how you can deal with the fake IDs. And you can use ARIMA modeling for that. So any time series based system that you want to study, there is a ARIMA which you can use, and that can solve the problem. Shweta, does that answer your question?
Yep, I think considering the time and our next friends are already in line. So Anshul, just post the link for the feedback. And guys, a humble request, please provide the feedback for this particular session on the link that Anshul is just going to post.
Sure. Meanwhile, you can just ask any other questions if you have.